a little bit of background. Dan had proposed a talk on gRPC and Protobuf to this past winter's NE Scala conference. And one of the pros and cons, I think, of that conference is that people get to vote for the topics, which is a pro. But this is also a pro, but in a sense a con. Like, it also attracts all these like heavy hitters that come in, and everyone's like, "Oh, I know that guy. I'll vote for him." Which sadly meant that Dan didn't get a chance to give his talk, and I was actually really looking forward to it. So I said, Dan, would you be willing to give your talk here at the Broad? For those who don't know, Dan is up in DISD on the Cromwell team, and he very politely said yes, and has been working feverishly on it for quite some time. So with that, we can hand it over to Dan to talk about some Protobuf.
Thanks. All right, I can start out here. I got some code to show later. But so I'm Dan Billings. I just started in May, so I've only been here a few months. But this is actually not the talk I proposed at NE Scala, because NE Scala was specific to Scala. And here I'm going to try to sell Protobuf and gRPC to anyone in any language. So it's much more, this presentation is much more general, but if you do like to talk about Scala stuff, I started this SIGFP functional programming thing. It's supposed to be like moderate to advanced level Scala if you want to talk about that sort of thing, so please join that. And yeah, my thoughts today are really with respect to Cromwell, which is the workflow execution engine that we're working on in DSP, and how this could apply to that if we chose to go that direction. So yeah, just kind of going through the structure. I'm just going to tell you what's wrong, why Protobuf is good, and then some ideas of what I think the grand vision could be. So it's kind of tough. Like I almost hesitated to accept this offer to do the talk because speaking generally about serialization formats is really not very interesting. I mean, if I was up here talking about JSON, I don't think anyone would come. It's just that it's Protobuf and people aren't using it, so it's like this kind of like googly sort of like ivory tower that Googlers are using, but not too many other people are using. But I think the bar to adoption is pretty low, so it'd be pretty easy to jump into it. So the issue with JSON and REST interfaces, to me, it's all about how easy is it to use. If you're using a JSON REST interface, you have to know what that API is. You have to know the endpoints. You have to know the JSON structure. You have to know whether it's a post or a get. I'm just going to pick on my own project here because I just want to show off what the problem is as far as I see it. And this is Cromwell's API as a REST interface. Let me blow that up just a little bit. So you see there's like posts and gets and endpoints, and there's some logic kind of mixed in to handle these interfaces and to send it to the right places. But basically the business logic is elsewhere. Like here is everything related to accepting data and sending it back in a particular format. And if you were tasked with understanding what the API to Cromwell was, it'd be pretty hard to just walk in here, read 350 lines, and say you understand what Cromwell can do. We do have good documentation. We have a nice Swagger service that does a lot of this stuff for you, but I don't think it's very easy to understand from a discoverability standpoint. So, and then the last thing is JSON types kind of leave you wanting. I mean, there's really only about 5 types, and some of them are like structural, like maps and arrays, and they don't really make any significant constraints on your type. So if you have a positive number, there's no way to encode that in your JSON. You have to do that, enforce that after the fact yourself. And then security, I'm going to touch on just a little bit. So enter Protobuf. It's a Google project. It's just basically structured type data that generates code in any of, I think, 10 languages now, something, maybe more than that. So on the left, we see this is a Protobuf specification for a message type and it has 3 fields. And on the right, you see some code using that data in 2 different languages. So there's the Java and I think C++. So what you're seeing here is like this builder interface everywhere that makes it easy to set fields. And they're not showing it, but it's, oh, there it is. You can read fields pretty easily. And it's just kind of a nice typed interface to use. So speaking of types, there are a lot of types supported. There's some really basic ones that you would expect, like Boolean string and maps, that sort of thing. They do have some interesting things like enumerations, algebraic data types or sum types. And then where I think it really shines is with number types. So they have unsigned integers, unsigned longs, basically, doubles, floats. And these all translate to nice types in every language that you're used to. So the compatibility is very good. I don't like to argue like because Google is a humongous corporation with unlimited resources, but I think it's worthwhile to note that they have this everywhere in all of their code from every service they use. So everything from Chrome into like inter-service communication, they have like 50,000 of these message types across 12,000 files. So they're definitely eating their own dog food. So gRPC is where the code generation gets really interesting. What you can declare in gRPC is these service interfaces. So we just looked at Cromwell's REST API, and using Protobuf, we can declare this interface, a service interface, an RPC interface, with all sorts of different endpoints. And this is known as an IDL. It's interface description language. I don't think that's particularly interesting in and of itself, except that it facilitates all these other things such as code generation, which is extremely useful. Under the hood, it's using HTTP2. Also not very interesting, except for the idea of server-side streaming is built in, and that enables full duplex. So there's no like command and response sort of facility. It's almost like a TCP connection. It's an open connection where they can send it unsolicited, and you can do the same as a client. So speaking of code generation, it's and gRPC I think is where it really shines. The code generation applies to both the server and the client code. So if you declare this interface that we saw back here, this will generate 2 separate pieces of code. One is basically a skeleton server implementation, and the other is what they call a stub client implementation. And again, you can do this in any of 10 languages. So your server can be implemented in C++. Your clients can be anything. And these show Ruby and Android. I'm thinking more like Scala and Python, really nice scripting experiences. So you can write short amounts of code, you get code completion, and you can do things quickly.
Are you thinking Riddle also?
I can't envision what that is end to end. So right now, no. In fact, I like to use this at all before I go to the fringes of Protobuf and write my own support for Whittle. So it's more like, yes, it'd be nice to have, but I think we should start with what we're doing already with our REST interfaces as they're implemented in Scala, which we're doing all over DSP. All right, so I kind of cut and pasted some code into this presentation because I don't necessarily like live aspects of live demos, like if things don't compile, things don't run, that's not very fun. So here I've just kind of cut and pasted the hello world gRPC specification, and that is this greeter service where you're saying hello to the server with a request, which is a Protobuf message, and it returns a reply. So what I'm going to show you is an implementation in Java and then client code in, I think, 4 languages. So we're going to skip this for now. This is just showing that it generates a whole bunch of code for you, which is nice for you to use. So the little snippet that we implement for the server they give us this abstract. I told you they give us a skeleton server. Essentially, it's just an interface. It's an abstract class, to be specific, that you extend, and then you implement the generated method that corresponds to the RPC call. So in this case, it was a say hello request, and this is just a little Java ease, but it doesn't actually return anything because this stream observer can take multiple responses. You can send multiple responses before you close the connection. So the hello request comes in here, and we're setting a reply as a new message and prepending the word hello. The way you respond to the caller is with this response observer that is given to you in the parameter with on next. And finally, we close the connection. This normally you wouldn't call this until you're totally finished, but you call on completed to finish the communication with the client.
Was all of that generated?
No, so this is the business logic. This is what was generated is this greeter impl base. So what's generated is serializing from these types to these rich types in whatever language you have, and then providing them to this interface to be interpreted however you please. So this, what I'm showing you is the business logic, and once we provide this business logic, and then we run what I'm going to show you next, basically we have a running server that will fulfill these requests, and we didn't have to use any JSON encoders or decoders, any HTTP server with special DSLs. So just showing you next, I mean I have this code later in the demo, but you're essentially using this builder pattern to declare a port, declare the service you're implementing. Greeter impl was what I just declared here, and then you call build and start the server. As far as the client for Java is concerned, it's another builder pattern here. Here we don't have to implement anything. We're the clients. We're just using the service that's provided for us. So we specify where that lives on the internet. Our security is just plain text because we're just doing a demo. And finally, you call this blocking stub. The only reason I'm using blocking stub is a synchronous call. They also have just stub, which is an asynchronous call, which it just adds a little more code to this slide. So I did a synchronous call. Finally, you build your request with this builder pattern, new builder, set name, and then you call say hello with the request and get your response. I'm just going to show you in all the different languages, and then I'll show the code running. So Scala is very similar code, declaring your client, getting your blocking stub, calling your blocking stub with say hello. I think I'll just skip these and go to. So this is all pre-compiled. Again, I didn't want to risk it not compiling. So I'm just starting the server. This is my Java server that I just showed you the implementation. Here I am in C++ world with my hello world implementation. The code's on the slide. It's all the same, basically. And we're going to call greeter client, just demonstrating that that works. It's very small. Same thing for Python. Go. SBT, I'll let it run. And you get the point. So suffice to say that the client code and the server code is very minimal. I only had to write a few lines of code in both to implement and utilize this service, and everything else is, all the glue is generated, and then it's leveraging things that are already implemented by gRPC, like the network server. So in Java, they use Netty, and all these other, every language has its own like network server of choice. But like as the client, you don't care. And as the implementer, you also don't care. You just want to implement the business logic, so that's what it gives you. So one interesting thing that you can specify is the idea of streaming a request and the response. So HTTP1 is all about request response. So you send a request, you get some data back, you crunch that data a little bit, you set another request, and you're just establishing a bunch of connections, but there's never a situation where the server can provide something, out of that sequence. So the idea that you can say a streaming client-side response is actually pretty interesting. I do have some example code here in Scala. Basically, let's see, this is Y. Here it is. So it's a little unfortunate. We are using the Java code generation, so we're using Java objects, which don't give you some nice things that Scala could give you. For instance, we have to declare this anonymous inner class with all of this interface implemented. I think Scala could clean this up quite a bit, but we use Java because it's stable and it works. And Scala is not an officially supported language. So anyway, suffice to say, we have these stream observers all over the place. So say hello it's kind of interesting because it switches what you would expect. It gives you what looks like the reply, and you return the request. That's actually not how it works, though, because what you're doing is you're declaring this stream observer that takes requests, and then at the end of the day, you're using your response provider or response observer to send back the replies to the client. So what we did here was, I think I have it somewhere where so I didn't do anything out of sequence here, but this is showing you that there's a stream from the client and there's a stream from the server, and you can schedule things that send to this stream observer whenever you want. So down here, I was just talking about the Scala example code. This is it. I think this is very succinct and nice to use. I have code completion, and it's not using curl, so I don't have to remember anything. Okay. Yeah, so this is, go ahead.
It seems very similar to Protobuf, like common object.
Yeah.
I guess the question from working with that, it was always if you didn't generate your client and your server from the exact same ID, if you modified the IDL, whatever the signature, and you didn't use the same, you would have obviously issues. If this is binary interaction, so if I add, let's say, 2 fields to my server object, but I'm still using an old client that doesn't have those 2 fields, I'm going to get I have to regenerate my client again. Is that correct?
Yes. So the way Google gets around that is they have static interfaces that are versioned by endpoint. So, and the endpoint is not like say hello as version 1. The endpoint is like, I'm going to connect to that server, which I know is a version 1 server with version 1 code. And if I have version 1.1, I'm connecting to a different endpoint. So there's never like you're connecting to the same endpoint but using different versions of code. You're only using one static version of the code at any time.
So we do the same port. So it would do that handshake automatically, I guess.
Yes. Yes. And the thing is, like, at low level, you can add fields to Protobuf. So you can add fields to Protobuf, and it'll still parse on the end. You can't change fields. You can't change field names. But you can change field names. You can't change their numbers. There's like certain things you can change, and it'll still be parsable, but Google gets around that by being very static and very specific about which version you're using at any time. Do you have a question?
Yeah, I guess I was kind of going to ask a question along those lines. Like, when you're developing stuff, it's often nice to iterate frequently. And so I was wondering if you could use, like, Protobuf. I know they have, like, optional fields or, have fields that may or may not be in a stream. And so, like a common pattern in a lot of languages is to add an optional parameter and still sort of be somewhat backwards compatible. And if you could play those same tricks even when you're in this gRPCR?
So Protobuf was always very aware of this required versus optional struggle. So in version 3, which is 2 years old, a year and a half now, everything is optional. And gRPC only uses version 3. So it kind of gets around that problem. I think the problem that remains is that in order to parse and create a rich object of this type, gRPC Java will say, well, yeah, you can pull this value, but if it's not, if it wasn't present in the message, we're going to set it to a default value. So like unsigned integer default is 0. Well, you don't know if the client set it to 0 or if it's actually 0. We get around it in Scala because you can set the fields to all be optional, which is ugly, but at least you're not parsing something that the client actually didn't send.
For those of us with scars from Corba, and so some of the things that caused both of those to fail was lack of interoperability and a requirement, well, lots of version dependencies, SOAP 1.1, even an Apache implementation version 1.1 of SOAP wouldn't talk to a version 1.12, and debugging was often hard. One of the nice things about REST is that you could always easily go in and examine what the request was and what the response is just in any browser. So maybe Google's just doing it a lot better than it used to be, but for those of us who saw the battle days, have you experienced that? What's your sense of?
Well, the interoperability is strictly at the protobuf level because all gRPC is doing is taking care of network layer glue. So gRPC isn't adding anything to protobuf. As far as interoperability, I mean, there are the gotchas that I talked about, like, the optional versus required, which they've made a firm decision in one direction. And then your approach to versioning, like if you change something that's a breaking change, you had better version your thing. But I think the same problems apply to JSON REST interfaces. Like you can either like add a new endpoint that takes everything.
That's I agree. That's just a
afraid of this
issue. It really was in the SOAP world just a minor change in the version of the code generator you were using would break the world.
Yeah, I used Protobuf quite a bit before, and I did find we had instances where we upgraded from 2.0 to 2.1, and they were not compatible. So it was
the version of Protobuf.
Version of Protobuf itself. Yeah.
But you can take a Protobuf message and add fields to it, and it's not going to, unless your logic breaks, it's not going to break anything. You don't have to specifically change versions.
That wasn't the problem. I mean, it really was the problem that if you were using the Apache version of SOAP 1.1 and you changed to Apache SOAP version 1.12, a client with that version wouldn't talk to the server of the older version, and the result was that it really dramatically impacted the tech stack that you had to use, and sort of defeated a lot of the purpose.
And the other issue relevant to what you mentioned is that you can look at them. I mean, they are interconvertible with JSON,
Okay.
so you can switch them back and forth any way you wish.
I was going to mention that at the end. If you need to fall back to JSON, you can switch back and forth. I think I saw.
I'm good.
Okay, we answered your question. Okay, so yeah, the vision. So I mean, the biggest one that I would like to see from Cromwell's perspective is the first one. I would like people to be able to use Cromwell without any prior knowledge, ideally with code completion in a nice IDE environment. So this is something that I don't think is possible with JSON REST unless there are tools that I'm unaware of. All these other things are kind of nice to haves. I think one interesting thing is that you could write a Protobuf specification for a service that doesn't exist yet, and you wouldn't have to be a programmer to do that. Like you could just declare it and say, look, it'd be nice if everyone had this because people want it, and it's very high level. And well, writing Protobuf is so there's no logic involved in Protobuf. You're declaring message types. So I would argue no, that it's not programming, but I guess this is splitting hairs somewhat. Yeah, and then ideally I'd never like to think about serialization again because it's just not interesting, and I think we're spending too much time on it, and that's the whole point of this is that I'd love to just focus on business logic and give the clients whatever they want and whatever language they're using.
Well, you're talking about serialization type objects, correct?
Yes.
Yeah, so I wouldn't say that's a disadvantage of JavaScript as much as a disadvantage of using a typed language. You don't have to do that if you're just like if you're taking a map from JSON and converting it to a map, right? You don't have to serialize anything. You just, you know what I mean?
So I think it comes down to knowing what's in your map or knowing what's in your data. So the reason I like types is because I don't want to have to come to the type with knowledge of what it has for me. The untyped object, I wasn't
trying to like, you know.
Yeah.
I wasn't trying to put down types.
Sure.
I was just saying, you know, serialization is kind of nicks you a little bit more in that particular environment than it does in an untyped environment.
Yes.
I would say.
Anyway, I'd argue it's worth it.
Yeah.
It does, but I think this is a great solution for languages that, you know, that are typed and you the struggle to like do all the right serialization, which is a pain.
Yep.
This sounds awesome.
Well, there's also the issue that the size of the serialized data are way smaller using Protobuf.
Right. I think was Google's primary reason for a binary serialization format is saving bytes, because they say they issue like 10 trillion per second or something. Go ahead.
I'm curious if you've used flat buffers at all. It's like the latest thing to come out of Google.
I have not. I've seen it, and it sounds interesting, but I'm not
It
using
sounds
it.
similar to Protobuf, but slightly more memory efficient and smaller. I have no idea if it works with gRPC or not.
So these are details I think that come with scaling issues, and I specifically did not address that because I think most people just don't have that problem. But when it comes to that, yeah, there are alternatives like flat buffers to consider to save you some memory overhead. Okay, so I just had some like miscellaneous slides that I thought were worth noting. So Protobuf and gRPC just using builder pattern everywhere, which I think is just very nice as a user because I don't have to think like, how do I add security to this? It's just like in the builder for the server. And as a client, I don't have to think about, you know, what port am I hitting, because I just like hit dot and it's the builder is giving me all of my configuration options. I think that's very nice to use. And then, yeah, I mean, some people just like low-level access, like HTTP headers and, you know, IP addresses and ports and all that sort of thing. And you can get that. You can drop that lower level with some particular objects in gRPC, but by no means do you have to understand this to write an implementation of a server. Yeah, so it's a hard question to answer. Well, what if I have a REST service that everyone's using? There are some things to do that can alleviate this, but I haven't done it personally, so I'm not sure how well they work, but I do have some ideas. So first of all, there's this gRPC gateway, which uses the fact that JSON and Protobuf are interchangeable. You cannot establish all the same, you don't have the same flexibility in Protobuf that you have in JSON. You have some limitations on like, you know, repeated fields and maps and enumerations and one-ofs and that sort, and algebraic data types. So it's not one-to-one, but you do have, if you can express it as a protobuf message, you do have this thing called a gateway, which will basically say, give me your protobuf implementation, and we'll create a JSON proxy in front of it that will accept JSON and forward it through to the protobuf service, which is.
What are the handle cases where the path contains, like IDs or whatever? I mean, how do you mangle, REST paths into data?
Right. So I don't know, but the gRPC gateway, I assume, has addressed that. Yeah, and I mean, this is something you basically can't just say, hey, today we're releasing a new version, and by the way, it's all protobuf. Like, you would lose a lot of people that way. However, I do think it's very easy to add a protobuf or gRPC service to an existing microservice ecosystem because the clients just change. Like, your client to that becomes a typed rich network object as opposed to an HTTP library with JSON as a payload. And then finally, if you are like great at shell scripting, then there's a shell scripting wrapper to gRPC. I don't think it's as easy or nice as curl, but it will work. So if you're really into that, then Polyglot is your solution. There's also a bunch of companies that are starting to use gRPC. I wouldn't say it's hitting like tipping point levels, but like slowly but surely you're starting to see some things in the ecosystem. The one I like in particular is the Scala support because they are because I like Scala and I like using it. They have nice things to declare objects and use them, and it ends up being a lot more terse than Java implementation. And I think it's comparable to Python, which I think is pretty good considering the Java. This guy actually works for Google now, but he has a consulting company. It's like 3 people, but I know the head guy is now a Googler, so they must think it's important enough to pay him to do it. And then finally, this is kind of interesting. I mean, the whole reason I came into this gRPC talk is because I was trying to play with Google's speech recognition API, and it turned out that they have a REST API, which they say, yeah, we support this, but if you really want the good stuff, use our gRPC interface. So I'll just kind of show you what that looks like. So their GitHub repo is here called Google APIs, and if you click on the Google directory, they list literally every service they offer is offered in gRPC, and I believe they're using this internally to do service-to-service communication. So you see here, they basically list all their services, and then the one I was using was the cloud speech interface, which we see here. It's 20 lines of code with great documentation, but they basically offer a synchronous call to recognize speech. They give you they call it long running, so they're not using streaming specifically, but the idea is that you're streaming bytes of audio to them, and at the very end of it, and they give you this operation so you can check on how the transcription's going. And then finally, they give you the bidirectional full duplex streaming, which is really cool, and they even note this method is only available via gRPC API. So they declared their inputs. The same thing, the recognize request, they call it streaming recognize request, declared as a stream, and then they return all the responses as a stream. And these responses are much richer. They give you, like, at what point in your audio did this transcription occur? And they have things like, what are the confidence values of that transcription? So it's just like this beautifully rich object that you get in your code, and it's very easy to use. It's very easy to generate code, and I use it for Scala, and away I went. Okay, I think we're almost. Oh yeah, I just thought I had to throw this in there somewhere. Just a direct comparison of like kind of the high level stuff. The one I want to point out that people always kind of think is the Trump factor is human readability, and I'd say like yes, that is true. There's nothing you can do to make like binary code very readable for a human being, but I would argue that you hit a very low threshold of human tolerance for JSON data. So just to keep picking on Cromwell, if you call hello world in Cromwell, you get this much metadata for basically like a demonstration of Cromwell. And when I get this, I just immediately like kind of step back and I cut this and I paste it into a JSON viewer on the internet so I can pick through it with some structure. Go ahead.
So, side anecdote, I didn't realize that we were forcibly pre-printing this with like we're actually not returning JSON, we're returning raw strings, and I didn't realize that. And I broke that, and read into what you will, but people noticed immediately, like our checkers did not, because they don't care.
Right.
But we got a lot of like, what the hell, I can't read this now. It's just like a bunch of JSON.
Well, people are reading this because they really don't have a choice. Like few people are out there writing a decoder for this amount of JSON. They're just trying to pick out certain fields from it that they're interested in, and then on top of that, they have to know what that they have to know the key name of that field, they have to know the type of that field, and if there's any sort of constraints they want to put on that type, they have to do it themselves. So just a lot of like overhead basically to using this amount of data, but it is technically human readable. Okay, yeah, and just like the one nice thing, I've touched on this a bunch, but the interface being like very terse is really nice from a maintainability standpoint. Okay, so that's it. So gRPC.io is the website, and check out SIGFP if you're into Scala like I am. Dave, what's up? Well, I just said if you do this, I'll help you if you run into snags, because it'd be nice if people started using it.
So, what is the story for, like, when I run an API server, my primary client in mind usually is a browser. What's the story there?
That's a good question. I don't have specific experience with it. I think the JSON proxy is probably your best bet. There are Protobuf libraries for JavaScript. I haven't used them. I'm surprised it's not one of Google's officially supported languages, because they're obviously writing a ton of code for the browser. But things like, security, I think there are sort of like contextual issues with JavaScript in the browser that you have full control over in all these other languages. So, yeah, I guess it's a long answer, but I don't actually know. So, but I'm guessing someone's doing it somewhere.
Well, Google's doing it. But it sucks. But that was 5 years ago. I think the documentation for their speech API that you showed is some of the best Google documentation I've seen, and also the only Google, like, the most trustworthy Google documentation I've seen. Like, I would believe it more than any other documentation, which is saying something.
Yeah, so one of the nice things of this was I used this and generated my own client and used that before I knew they had an official speech Java library. So as far as like discoverability, if we like did like Google did and published all of our APIs in one repo, someone could just like generate clients all over the place, and then they don't have to like go find our tool for doing X. Khalid?
Do most people just distribute profiles from what you've seen, or do they generate
So if I were doing it, I would distribute clients in 10 languages, as many as I could generate automatically for every release. My server's in whatever I want to do my server in, so I'm not, if I was releasing it, I would release whatever my implementation was. But no, if you just distribute Protobuf, it's working for Google because they're Google and you want to use Google services, so you'll go through the trouble of generating clients. What Google has the resources to build on top of that Proto distribution with another rich client that is even easier to use than gRPC generated code. But most places don't have anything like that. So no, I think you would just do the generation for people because it saves them a step. So,
you mentioned Swagger before.
yep.
Is there an HTML generator for Proto? Or for
That's another great question. I don't think so because of the Protobuf Protobuf from the browser issue. I wonder if you could, if something in that gRPC gateway would address something like that. I imagine it could because it has your whole interface declared.
And you give comments inside your interface.
Yep. I haven't seen it, but I think it could be done without too much overhead.
You see, the other thing I was thinking about was, like, if you generate Java doc as well, Java code. From the comments, that would be nice as well.
Yeah, there's a lot of nice documentation support around Protobuf. Like you can generate like web page, Java docky type things with documentation from the proto file displayed on a nice web page.
So it would be kind of like Swagger that shows you the APIs, but you'd be able to run it.
It shows you the APIs, but what?
You would actually be able to run queries from that.
Right, that's right. Okay, yeah, I get it. See, the thing about Swagger, the reason I brought up Swagger is because for Cromwell, we're maintaining two pieces of code. One is our Scala implementation of the REST API, and then we're turning around and writing a YAML file that declares all of our endpoints with all the acceptable types and JSON payloads that they take and that you submit and return. So we have two sort of like large maintenance endpoints that sometimes, let me tell you, like, Swagger gets out of date because we're focused on the server implementation, and then it's like, oh, yeah, it's Swagger. Yep.
Yeah, on our project, our code basically does the Swagger creation for us automagically, so we don't have to manually edit a YAML file.
So what are you writing your server? How are you implementing your server?
We're writing it in Python using a foundation that was created by the Firebrowse team.
But Swagger can generate YAML from it.
Yeah, it automatically generates it.
That's by the early days of the tree.
Yeah.
So you can do that in Java too.
Oh, okay.
So the problem is, like, it's and people have tried to make it possible to do even for Okta HTTP, well, Spray, but Okta HTTP, but it's just not, it's really like the annotation principle is really just not compatible with that. And we were doing it first, but it caused us to have to compromise the shit out of our routes. Like we had to make much more boilerplate routes to make that work when we could just use Okta's kind of more nicer routing, but then we lose that, so then we had to go to the manual generator.
If I recall, on top of that, there were still bits that you had to remember to edit that weren't just the code. Like, you still got into this, like, divergence problem that just wasn't quite as bad. And so, like, it's making our code ugly, and it's diverging anyways. We'll just say screw it.
Just a comment, even beyond the RPC stuff, Protobuf can be great for like storage as well. If you need to store structured data serialized in a bucket or on disk or something, Protobuf is really good for that.
Arrow's really nice for that too.
What is
Arrow?
Arrow?
And an Apache.
Okay,
Yeah.
I use
Sort of thing.
Avro. Yeah.
Yeah, we used it for stuffing payloads in like message queues, both in like RabbitMQ and then like at Amazon SQS. So anything that takes a byte payload, you can just stuff Protobuf in and get it out. Okay, thanks everyone.